couple of things to clarify. Last week, those of you that were here, we talked about myths, legends, and tall tales. And I have to admit, I got a little carried away. I mentioned that the HPC also tells you what color you can paint your house. They don't. They have suggestions. So I got a little carried away with myths and legends as well. So I just wanted to clarify that with you. Other than that, we'll get started. I do have a disclaimer. Today's topic is geology. I am not a geologist, okay? And I'm not going to spend the time with the details. We're just going to do real simple geology. Hopefully by the end of the day, when you walk outside and you look at Smuggler Mountain, or Aspen Mountain, or some of the areas nearby, at least you'll have a rough idea of how it became what it is today, and you'll have a little bit of an understanding. The other thing I want to do is lead you into the other question that I get often is, okay, how did the prospectors know there was silver, and what are they looking for? And we'll learn that through geology today. So geology, I'm surprised with the title that so many of you showed up. Geology is rather complicated. It is a science, and it is quite complicated. As a science, you need to be able to describe in intimate detail what you're working with. For example, a common rock around here, I have to read this because this is not my language either. An indigenous, intrusive, quasi-horizontal chronolith comprised of antemossing dictoliths whose distal ends curl like a harpolith, thin like a phenolith, or bulge discordantly like an acantholith, or ethymolith. Does anybody want to try that? No. Good, you're in the right place. I think what they're describing is a piece of quartz. Okay, so today we're going to call it quartz, and we'll stay with that, okay? So that's where we're going to go today. First of all, we do need to understand a little bit of geology. There are three kinds of rocks. There's igneous rock. That's a rock that is formed from molten material. And the most common would be granite. And of course, there are dozens of types of granite. We'll just call it granite for now. And that's igneous. The second type of rock is sedimentary, and that is sediments in an ocean bottom or a lake bottom or a swamp bottom, whatever washes in. Those are materials that have the ability to cement themselves together and create a specific layer, and those are what we would call shale would be a good example, or limestone. And those are two things that we really need to know about here. The third type of rock is metamorphic. And metamorphic is one of those is any rock that's been changed from one rock to another rock. The easiest example would be limestone, which when pressure and heat is applied, it becomes marble. So we have some marble nearby. You may have heard of marble, Colorado, or the black marble of Conundrum Creek. So those are the rocks that you need to know about. And of course, in Aspen, we have every kind of rock there is. We have all three. Mountains, there are four kinds of mountains. I can think of three. We have all four, okay? When Ferdinand Hayden came through this area, he began a series of explorations of the West, sponsored by the government, what became the USGS. He began in 1871 in Yellowstone. In 1873, he came to Colorado and basically did the western slope. And it was the most detailed geological descriptions, but he was also doing the botany, the economics of the area, etc. So it was a huge endeavor. And it was very, very specific. And he also made a map, not as detailed as this because geology has come a long way, but his geology map of Colorado was over here. And this is the 1881 printing of that geology map.
Wow.
Oh, thank you.
Show it.
And this shows the state of Colorado and the state of geology at that point in time. This is the type of material that is here at the archives. If you want to do research and you want to see the real thing, this is what you do. You get a hold of Anna, right here, Anna Scott, and she will help you find exactly what you need. This is the type of material we have here. So please, if you want the real story and you want some detail, we have Hayden maps, we have Spurs Atlas. There are thousands of maps down, well, maybe not thousands, but we have hundreds of maps downstairs for you to look at. So that is what happened. So Hayden came through here and he began to describe the geology. By the time he came, he left Leadville, which by that time was not Leadville. It was Oro City at that time. And when he left that, he came up Twin Lakes, up Lake Creek, and he took the South Fork of Lake Creek and went over what is now Lake Creek Pass. That was called Red Mountain Pass back then. And he went into the Gunnison country, and he came along this edge that's south of us, and he eventually got to Rock Creek. Well, Rock Creek is now called the Crystal River. And he came down that to about where Carbondale is today, and then he came up this direction. We're not exactly sure how far he came up, but we do know that he had about 100 men with him, and they spread out in groups, and they began to describe the geology of this area. And this is what we came up with. So he was pretty accurate in trying to figure out what had happened. The first thing he said was, and he said it several times in his diary, or his first report. He published his first report in 1874. And he, several times from the time he got into the Gunnison country until he left here, he kept saying, this is the most confusing, complicated, absolute mass of geology. Everything that's ever happened has happened in this one quadrangle right here. It's all here. And he did his best to describe it. So let's go back, take another step backwards for a second. What do we have here? What we have here are two different mountain ranges. We have the Sawatch, and we have the Elk Mountains. But we also have the ocean. This was an ocean. This was down at sea level, or below sea level, a long time ago. Let's see, I don't know how complicated I want to get. Okay, the Earth had crust. The crust cooled, it created cracks when it shrank. More igneous rock came up, built mountains. Eventually we wound up with the Sawatch Mountains, which are called the ancient Colorado Mountains. And they were the original mountains here, and they were 2 or 3 times higher than they are today. Okay, they were way higher. We're talking millions, billions of years ago, okay? The timeline of geology is massive, okay? If you took 1 mile and spread out a timeline, humans are about 1/4 of an inch. In the last 1/4 of an inch, okay? So if I say a mountain rose, I'm talking about 6 or 7 inches a year for a couple of billion years or a million years. So keep that in mind. It didn't happen overnight. So the original mountains were there, the original Rockies. This was surrounded by an ocean, and this was down underneath the ocean. And that's where the sedimentary rock came from. So as debris would erode off of the mountains, it would fill the bottom, and that would become your shales. Shale is mud that has been compressed to the point that it becomes shale. A lot of shale has oil and such in it because it was maybe in a shallow sea or a swamp, and all of the debris that fell in there, the plant debris, etc., would get in there. That's why we have oil shale, for example. So that is shale. Now, in that ocean, there were several series of periods of time when the ocean was overpopulated by crustaceans, shelled animals, and they didn't have any predators. And the theory is that they died off in mass, and they would fill the bottom of the ocean floor hundreds of feet thick. Well, that pressure eventually collapsed it and pushed it and squeezed it and turned it into limestone. So that's our limestone. So we have shales and limestones as the ocean bottom. And it processed like that. I may get these out of order, I apologize, but eventually what happened was there were some batholiths. A batholith is a bubble of molten rock about 150 miles down, 200 miles down, and it is trying to rise. And as it rises, it pushes whatever is underneath up. So it began to put some hills in this flat ocean bottom, and that became the Elk Mountains. So the Elk Mountains are granite with ocean on top, the layers of ocean on top.
Makes sense.
Now, to help things off, we have this thing called plate tectonics. And what happened was the Sawatch Range, it's there. It's got the mother rock underneath. It's not moving. So as the Elk Mountains moved up, they tried to push themselves over the top of the Sawatch. That's not going to happen. So what happened was that ocean floor came up in a big flat pie. Think of a Oreo cookie with layers, a double Oreo cookie, okay? Only it's about 12 miles wide and about 50 miles long. And it's setting right here about where, from Castle Creek to about Difficult. And it's just setting here, and it's at an angle. And what's it going to do? It's going to start cracking. Oh, I've got props. You didn't hear the saw going there? Okay, so we've got our layers of ocean floor. What happens when it goes up? Now it's disjointed. Now we have a crack. Now we have a fault. Okay? So that's what's going to happen, and that's why in some places you have one layer of shale, and in another place 5 feet away, it may be limestone. And they're on the same level. So that's what's going to start happening. And of course, it's going to go like this. Well, what happens if you've got a big piece like this? It's going to crack like this as well. And these pieces are going to slide like this. So we have unbelievable movement taking place all of a sudden. Well, that's good for us because that's how the silver will eventually get here. But that's also why when you look at Aspen Mountain, especially Shadow Mountain, you can see that it's setting at about a 60-degree angle. And that's what happened when it slammed up against the mountains and slid back. And if you look at the top of Shadow Mountain, that's where the striations of the sedimentary rock are. Whereas if you go around the other side of Shadow Mountain, that's where the granite is. So there's granite underneath that. Underneath the maroon bells, it's granite. But what's on top is ocean. That's why you can find seashells up there. Okay? We find seashells around here. There are seashells in the shale as well. So that's a rough idea of what happened. All right? So everything kind of settled down. And this ocean was much higher. It was about the height of the Hunter Creek Valley. And you know how high that is. That's about 632 feet higher than the old art museum. We had another earth-shaping event occur, and that's the Ice Age. And we had glaciers. We had 4 glaciers come through here, and they began to carve these valleys out. They followed the small rivulets of water, and they began to carve the valley. The first one that came down the mountains, we had 4 of them, 4 major ones. The first one that came down the valley came down and it left a nice level platform. Now, if you look off at the edge of Red Mountain and you see Starwood's all of a sudden a nice level. That's the bottom of the first glacier that came across and scoured the valley. And that was how high this valley was. The second one that came down came a little lower, McLean Flats. So if you look at McLean Flats, that was the bottom of the second one. The third one came down and scoured out the valley. The airport all the way up here to the Holden Roll, just a couple blocks away, that is the third platform. That's the bottom of the third glacier that came down. And the fourth one, for those of us over in the east end of town, the fourth one stopped at the Roaring Fork River. When you leave City Market and you cross the river, you start to go up the Cresta House Hill. Do they still call it the Cresta House Hill? So the Cresta House Hill is the terminus of the last glacier that came through. So that's why our yards are full of nice little round rocks. Big round rocks. So it had pushed all of the debris down, and that's where it stopped. And that was the debris it was pushing. So if you go to Ute Cemetery, you're standing on top of that terminus. It kind of goes from the Snyder property around to the Aspen Club, and the river has finally cut through it. Another example of a terminus lane is at the ABC, that hill, I call it Deer Hill, the hill that's behind where the old 84 lumber used to be. That is a terminus. So that happened. Also, something else happened. I told you that there are cracks. We have cracks, and these are called faults. And sometimes they move this way, and sometimes they move this way. Well, there is a huge fault that starts up by Ashcroft and basically follows Castle Creek down to Red Butte and then heads on down almost all the way to Glenwood. And it is the Castle Creek Fault. And it's quite famous. What happens occasionally is that a fault, I don't know how I'm going to do this, but a fault may actually move enough to break a piece off. And there is a broken fault block, and it's Red Butte. Red Butte is an entire piece of mountain that was cracked off, and not only was it cracked off, but eventually it flipped upside down. Because the rock on the top is older than the rock on the bottom. It's not supposed to be that way. So that's what was happening with the environment. So that's a basic idea of what's happened around here and what you're looking at. Now, silver is here though, and that's the one unusual thing. It's here and it's not anywhere else. This is a piece of silver ore, and it is in, the white rock is called barite, and the little gray spots that you see contain some silver, and the green spots are copper. Silver, lead, zinc, copper, gold, mercury are on the same place on the chemistry chart. Silver is 46. They are amalgamous. If they are near each other and they have the opportunity, they will collect together. Aspen does not have gold, but we have the lead, the zinc, and we don't have the mercury. So this is called barite, and we'll talk about it a little bit more. But this is what it looks like. And that looks just like a white rock, right? Yeah. I don't know if it shines in there or not. I'll pass that around. You see the silver? Yeah. This is about 6 months old. Comes from the Smuggler Mode. So that's what they're looking for. So how did it get here? Well, remember these cracks that we had? They separate, or if they aren't separating, they are crushing each other. And the crushing material in between is a fill or a replacement material. And it's that replacement material we are looking for. That replacement material is, generally we call it breccia, B-R-E-C-C-I-A. I hope I'm pronouncing my geology terms correctly. So it's that replacement rock we're looking for. And generally it is between two layers, specific layers. It's between the very soft limestone and the slightly harder shale. In fact, we even have a name for the shale and the limestone. We have a generic name, we call it Leadville Limestone, and we call the shale Eldon Shale. And so if we're looking for silver, that's what we're looking for. Now, some of that material is crushed up rock, it's crushed up limestone. It looks something like this. This is some of that limestone. And this is brown. This is what we.
I'll keep
Thank you, Lisa.
I'm watching.
I'm going to hold this in my hand. This is coming up in a minute. So this is some limestone, and you'll notice it's very brown. The miners call this brown limestone. The brown is because of the iron oxides. The iron is rusted in it. It had some iron. So this is some of that replacement. This has been crushed several times and moved around, and there's a little bit of crystal in there. That's calcite, I believe. So that's what we're looking for. We're looking for the rock that's been disturbed. So, and I'm getting kind of ahead of myself, so let's go back a little bit. This is a glacial valley, and this is the bottom of a glacial valley. This is the last glacier that came through, and you may recognize that as North Star. And if you notice, way over in the horizon almost over here is Red Butte, upside down. So this, oh yeah, you're looking west, you're looking down toward the city of Aspen, and this is the bottom of that last glacier. And along here, this is filled with glacial material, and that's a lateral moraine. That's the debris that's left. We don't find the bare rock too often. What we're going to look for are the other sides.
What do you think the date of that?
That photo is probably...
It's a glass plate negative.
Yeah, it's a glass plate, and it's not detailed enough. If I could see the hole, then I could date it. But it's probably 1890, 93.
So the road is there, but it's probably gravel.
Yeah, that was the road over Independence Pass. That's the stage route.
Wow.
Yeah, we still use that. The last lecture is transportation. We'll talk all about it.
Good plug, Larry.
Oh yeah, I'm in PR. Good.
Extra points.
You guys are good audience. All right. So that's what happens. It flattens out and it becomes a moraine, and that's a bottom moraine. This is, they have a name for this. It's in the wrong place. This rock is in the wrong place. And it's started to round itself. This is what happens to rocks when a glacier starts to come down. It moves massive massive quantities of rock. It crushes them, it rolls them.
Erratic.
The more round it is, the further it is traveled. And you will find these all over. There's a rock about half this size on Ute Avenue, right by the Gant, right there by their little, I don't know what it is, the snack shop or whatever that convention room is. Right in the back, there's a round granite rock. It's about 6 miles away from wherever it came from. It's in the wrong place.
An erratic.
The glacier, erratic, that's it. You took the class, I didn't. It's an erratic piece. So,
It's like the survey stone on it.
yeah, so, yeah, and this is, yeah.
Yeah, that's an erratic sitting on.
Yeah, do you know that we have an historically designated rock in the city?
Yeah.
We have an historically designated rock in Aspen. It is on Hyman Avenue in the East End. It's right behind your house, a block away from your house. And it is historically designated because it's so out of place. If you can imagine this, when the prospectors came here, there was just sagebrush down here. And you need some points to measure off of for your surveys. That rock on Hyman Avenue is one of the very, very important key survey rocks, survey points. And it's extremely important for us to have that. So we have an historic,
Hyman and where? Where is it?
It's
Hyman?
between
It's-
Cleveland and
West End.
West End.
Yeah, it's between
I wanna
Cleveland
say
and
like
West End. It's on the south side.
700
And it's
east.
one in from the corner from Cleveland.
It's in the
So,
700 east.
It's in their front yard, yeah.
Yep.
Yeah, it's in their front yard. They have an American flag sometimes sticking out of it.
And there's still a drill bit.
And we can thank Wilkinson for that because he had to prove some of his mining claims. And he went to the city and says, you can't build a house there. We have to keep them on. And it's that important. So I don't know if too many towns
It's
have had.
between
Well,
Hyman and what?
maybe Plymouth Rock. But that's it. So if you look around and you're hiking somewhere and all of a sudden you find a rounded boulder that is granite and not limestone, the glacier moved it. Just to give you an idea. Now the glaciers did quite a bit. If you're up Independence Pass, up near the grottos, you will find that the glacier was so. This is the hardest rock, and this is the oldest rock we have in the valley. This is some of the basic granite. But you can see where it actually took a rock and scratched this very hard rock. And there are scratches up there. If you go to the grottos, a lot of those rocks you can see where it's scattered. And there are some big rocks sitting on top of the flat for no apparent reason. That's when the snow finally melted, the ice finally melted. They were suspended in or on top of the snow, and when it melted, that's where they set. And that's why they're out of place. Erratic?
Erratic.
Okay. Okay, I got it. I'm learning. I might take a geology class. There's the grottos, and that gives you an idea. This is the oldest rock in the valley, in Pitkin County. Is right up around the grottos, and that's the oldest granite that we have. And you can see the erosion power of mud and silt and water and ice. It's pretty amazing. A lot of that happened. We have a volcano. Did you know we have a volcano? If you go up to past, not Grizzly Reservoir, but to Grizzly Lake, that is a cauldron of a volcano. And that volcano did not spew lava and basalt like we're used to. It exploded and created massive quantities of a light rock dust called tuff, T-U-F-F. And that tuff, you'll find tuff, piles of tuff several feet thick in various spots up around Independence Pass. Most of that eroded and came down this way. If you're familiar with Creed, Colorado, that was one massive volcano, and that's all tough material. So I'm learning my geology as we go along. So that's Red Butte, one more time. And you can see that the moraine, the bottom moraine of Castle Creek, it shows, it turns out to be pretty good for farming. That was a potato farm for a long time. So just to give you an idea, and here are some of the plateaus. This is that first glacier that came through.
Mhm.
Yeah, that's the first one. And that's at about the level of Hunter Creek. Now, Hunter Creek drops off 600 feet. That's called a hanging valley. That's the term that we use. And it just means that the glacier came down around. It didn't make it all the way around. It wasn't in the Hunter Valley. So it came around and it just cut off the bottom. And that's why we have that 600-foot drop at Hunter Creek. And of course, Shadow Mountain. Shadow Mountain is a syncline. A syncline and an anticline. But you begin to see, here's where the layers are. And this buckled at some point, and this is the limestones. And if you go down around the back, there's the granites. The granites are underneath this, quite a ways underneath, hundreds and hundreds of feet underneath. But they push this up, and this is that Oreo cookie that cracked in half. And that's one of the pieces, and that's what we're looking for. And there is a fault that goes right through here. If you go down one block down and look over toward the Pride of Aspen, you'll be able to see that fault. It's pretty well defined. And here are some of the limestones and shales that you can see. And now you get an idea of the ocean. And this one's not tilted too bad. Aspen Mountain's tilted almost 60 degrees. So, we come to silver. Remember the cracks? Those are called faults. Well, that's where the debris was, and it's a softer rock. At some point in time, some superheated water came from way down low in the earth. And it was hotter than boiling water because it was contained under pressure. So it was extremely hot. And silver and lead and zinc and copper are soluble. So the water had microscopic pieces of silver, lead, and zinc, and traces of copper. And in one case, it also had barite. Barite is very soluble as well. So this was like a mud. And in fact, barite is used today in the oil and gas industry. They take barite, they mix it with water, and they use it for specific gravity. They can put it down in their mine casings and keep things separate by how much, how thick they make it. So barite. So that's one of the materials that came up with the water. So if I can find some barite with gray lines in it, I'm probably going to find silver. And that piece I passed around shows you exactly what can happen. So we start mining. What happened was that water came up and it hit the harder shale, which they call dolomite, and the limestone. Well, limestone's a bit softer, it's very porous. So in some places, it basically started to melt out the limestone and mix with the limestone. And so now there are bubbles. A lava lamp. You know what a lava lamp looks like?
Yeah.
My mountain is a lava lamp. It has these weird bubbles. And that's where the ore is. That's where the silver is. And that's the way I try to describe it. The only problem is, remember it's all cracked. It moves this way and that way and this way, so I might have half of a bubble here and then it disappears and it's over here, it's down there. We'll do that in the mining wall. So the other extraction is, of course, the geology has created a wonderful environment on the surface as well. So we have extracted the geology in one way or another, either on the surface or underneath it. and we have used it to our economic advantage. So, how did the prospectors, let me go forward. This is Smuggler Mountain. If I'm a miner and I come through here, what do I look for? This is all covered with trees. What I'm going to look for is an exposed crack, and that's called an outcrop. And that's the easiest way for me to find it. You see, the problem if I'm up here on Aspen Mountain, or on Smuggler Mountain, there's 150 feet of glacial debris. So I'm not going to find any traces of limestone or shale up there. But on the side of the mountain, I might be able to find it. And they found a big crack right there. Well, actually, it's right there. And that crack led them to, whoops, I want to go back. And this is what the geologist would do if he were looking for the silver. And what he's looking for is this porphyry right here. This is the zone where the Sawatch Range is over here, the Elk Mountain Range is over here, and they are pushing each other, and this is where all the problems are happening. So the mining, the silver contact is basically right along this line, and this gets nice and fat on Aspen Mountain. So that's the area that they're looking at, and this is the contact fault right here. That's what they call
it. Your house.
No, we're over here. You're fooling me. No. Let me see. If I walk down here and I go, yeah, our house. Well, there's the cemetery. So yeah, you're in bad territory. So this is a very simple map, and it shows some of the dolomite and the part of quartzite. So anything right in this area is likely to have a possibility of silver.
Who prepared that map?
This was prepared by D.H. Rolfing in 1925.
Oh my God.
It's in our archives.
Huh?
It's in our archives. No,
Yeah.
no, 25.
Yeah,
1925.
25. Yeah, and D.H. Was the son
DP.
of
It was DP Rolfing.
D.P., yeah. And there were 3 sons, and they are just like totally awesome mining engineers. And the irony is DP stands for Durant P. Rolfing, and he died in 1937 in the Durant Mine. Isn't that an odd an accident? So there was mining in 1937. So that gives you an idea of what the geologist would see if he were looking at this. The miner would have to look for something else. Let's look at Aspen Mountain. This is Aspen Mountain, and this is Spar Gulch, Kleenex Corners right about here. This is the Compromise Mine. That's where the cabin is today, and we'll talk about the Compromise in 2 weeks when I have to sue David Hyman. We're going to sue J.D. So right here is what we're going to look for, especially up this gulch. I think this ski run is Queens. Yeah, something like that. I don't ski, so.
So great.
So right through here is the really important spot we're looking at. And I should point out this big pile right here. That is after the glaciers. There was a massive land movement, a landslide. This was once all up here. Okay, just saying. We might as well have fun with it. So this is the geology, and here we go again. This is what we're looking for. And look at it, it's right there. But look at what happened.
Oh, yeah.
Okay? That's going to create a big lawsuit. If this is mine and it disappears, do I get to pick it up over here? Think about it. We'll talk about it. Jerome Wheeler doesn't think so. But so this is where it comes, and it comes right across. And as we discussed just last week, there is one tunnel, comes right over here past the AJ, right down West End Street, between West End and original and goes right on underneath the river and back over to the Moe.
Wow.
So that's the one tunnel that's underneath. Did somebody read the paper the other day? Somebody did an editorial or a letter and said, "Oh, over in Centennial, all the mine shafts." One, and if you were here last week, one man's abandoned mine shaft is another man's abandoned
Outhouse.
outhouse.
Larry,
What a
can
coincidence! Yes.
I just want to know, so when did Aspen Mountain fold in? Because it's a folded mountain, right?
It's a folded
So it
mountain, and I have
collapsed.
to look up my Paleolithic, Silolithic.
But it was before, like, this formation and stuff happened,
Right,
right?
right.
Long before the,
Long before.
Didn't West Aspen come up in a Pluton and?
Yeah, it was a Pluton that created that, yes. And I know that because I read that. I don't have a clue what a Pluton is. But you're right.
A horse,
Yeah. Yes.
Does the yellow vein continue into town?
Yeah, this right here goes right underneath. It gets real wide right in here, and then it goes underneath very thin, and it gets very thin to about where the Smuggler is, and it gets pretty much the contact is between the Clark Fault and the Smuggler Fault. And then we have other faults that come in perpendicular, and that would be the Delta S fault and the other faults. So, and that's very important because where you find a fault hitting another fault, if these are faulted this way and then you've got a fault coming in this way, this is most likely where the most disturbance has been. And that's most likely where you're going to find the pockets of silver. And yeah, we're getting very close. I'll tell you about that.
Well, the red
I'm going
line,
to get as much time with this as I can.
the red line stopped because the town is built on top of gravel.
Right, it's what's left over from the glacier that came through. And that's why there aren't tunnels from the Jerome Hotel to the Wheeler Opera House. Because you're not going to build a tunnel through that. Even underneath Hunter Creek, the Cohenhoven Tunnel, Burton had to invent all kinds of new ways to get through there because they hit a sand dog, which is just lots of soft sand. And he had to invent new ways of timbering. And there are mining books talking about Burton's inventions and how he was able to build the Cohenhoven Tunnel. He was quite an inventor. So that's Aspen Mountain. Now, to see how complicated it is, this is that gulch where the compromise is. And I'm going to have to flip through here because I don't remember the names of the mines. But if you'll notice, there are some numbers there. And let me look them up because I get them mixed up. The number 1, which is right in front of you, is the spar. This is the spar. Number 2 is the Vallejo. Number 3 is the Emma. 4 is the Aspen mine. Bad mine. I'm going to have to sue them. Okay, and the Connemara, and then the Jefferson Davis is up there. Notice how close together they are.
Yeah.
So there's a lot of conflict here as to who might own what. And that can create another type of mining, and it's called lawyers. There are 3 ways to mine. You can dig it out of the ground, you can litigate, or you can paper it. Sell fake claims. So that's how complicated it is. Today, that cabin that is down there, it's down about right here. Okay, and that's the compromise. So, this is what they were looking for. This is an outcrop. This is pretty defined.
Yeah.
Limestones, shale. The fill dirt in between. That's not silver, but there's a darn good chance if I follow it for a while, I may find something that looks like this. This nice dark stuff right here, that's part of the fill. This is part of one of those cracks. It goes in the Smuggler Mine. It's between the Clark and the Smuggler Fault. And if you look at it in bright sunshine, there's green right here. Here's the copper. There's a little bit of silver in here and a lot of lead and some zinc.
Is that the blue lead?
This is the blue lead. And I'll pass that around. That's what we're going to follow. Now, if I follow that in the Smuggler Mine, if I find at the Clark Tunnel, there's a little tiny piece about as big as my little finger, and it's clay. And it eventually gets wider and it turns into this. And when you follow it, it gets about this wide, and about 50 feet further, boom, we've got a bubble of oil.
They got really excited when they found that.
They found out and they started going, and that's why they do it. So if you get an opportunity to take a tour in the Smuggler Mine, that's one of the things that we'll do. We'll take you right to it. So this is the glass plate negative as printed. I had Megan flip this, and I didn't put it on here. This rock right here appears to be the same rock that's up there right now. And I don't think this is the Smuggler. I thought this was the Smuggler. I think this is the J.C. Johnson right above the Smuggler when it was first started. So when the prospectors came here, they didn't have that geology map that's all painted. They had an idea that if they found Leadville Limestone and Belden Shale, and there was a crack between them, go for it. And they did. And Smuggler Mountain, that's the best, that's a beautiful fault. I mean, that just shows you exactly what they were looking for.
I'm so sorry, Larry. So is that the apex then?
Well, no, yeah, that is the apex, yes.
A vein.
That is where it is exposed on the surface at its highest point.
Yeah.
So that is the apex. When it's exposed on the surface, that's the apex.
That's what, okay.
So I get to follow this as long as I want. Even if it crosses to the neighboring sideline. He's not going to be too excited about that, is he? I'm going to have to sue him in 2 weeks.
It'll take you 3 years.
This will give you another idea. Now, they took the color out of here,
Right.
but this gives you an idea. And here's that contact again. You see how wide it is here? And it just keeps getting more and more narrow. It's very interesting. The ore over here is not in the barite. It's in the limestone. And over here, it's in the barite.
So where would the most silver came from?
Smuggler Mine.
Good segue.
Yay! I don't know if I'm ready to do that. Let's see. I've got some pretty maps. These are just some maps that give you an idea of how complicated it is. And again, the one on top is Aspen Mountain, one on the bottom is Smuggler Mountain. And that will give you see what we're up against? You can be going along just fine and all of a sudden it disappears. Do you go left, right? Do you go up, down? Where do you find it? Or do you just give up? Depends. So these are just some other types of maps that show you the different layers. And again, the city of Aspen is under that. But this, what I just showed you a minute ago, this is Aspen Mountain. Turlock Park is up here, and Turlock Park has what we're looking for. But right in here, this is it, Smuggler Mine's right there. So that's what we're looking for. This contact basically starts at Ashcroft and goes past gypsum. But it's so intense and so easy to get to here, and rich. Now, this is Aspen Mountain and Smuggler Mountain on the bottom. And the Smuggler Mine shaft is right here, and I believe that's the Delta S. Yeah, we'll just go through it. So it gets complicated.
You're on my land.
You're on my land. Yes and no. You are allowed a rectangle, it should be a rectangle, sometimes it isn't, should be 300 feet by 1,500 feet. And if you laid it out properly, the outcrop is right there. That's the fault. And it's in the middle. And because I've laid it this way, I think that it starts somewhere over here and it goes this way. So I'm going to get the benefit of the most ore out of it. So that's what I'm going to try to do. I am allowed to the inline. The next guy, he gets it from the inline. However, if it, for some strange reason, dips, spurs, or changes, and it happens to drift this way across my sideline over here, who owns it when it gets to the side?
You do.
Mary Rita.
We'll see.
We'll
She
see.
owns both,
Oh, the apex sideline. Very controversial. So, anyway, it's not as simple as it looks, but this is why you have claims that overlay each other. This guy thinks he's got a vein going this way. This guy thinks he's got one going this way. This guy thinks he's got one going this way. And this guy probably thinks, I don't have anything, but if I lay out a claim, I could sue this guy and say it's mine. So that's that other type of money. So that happens, okay? This is a good example of Aspen Mountain, and here is the Durant and the Aspen. I want you to take a very close look at where the Aspen is and where the Durant is, because they don't like each other. One of them has the apex and one of them has the sideline. But notice what they did. They started with their discovery shaft near the middle, and this is where the ore was discovered along the surface. So that's what they're looking for, okay? The high-grade stope, that's in the compromise today. So even though they are not next to each other, the Durant and the Aspen, they could have that same vein. They did have that same vein. Do you think it's complicated?
Yes.
I just thought I'd throw that in there. That is looking down over by Smuggler. You can see it up here on the top. And the Emma, there's an Emma on Smuggler Mountain also. And those are some of the tunnels that are in the mountain here. The gray spots, that's where the silver came from. The gray spots that you see here, these are now hollowed out. Those are hollow spaces inside the mountain today. And they are massive, massive. The one in the number 3 in the Smuggler, I can probably put 2 or 3 Hotel Jerome's in it and still have room for parking. Ooh, I didn't say parking. So, after you sum it all up, I spent 2.5 days with Ralph Stager, who did his master's thesis on the Smuggler Mine. He is now, I believe his title is, he is the president of Overseas Mining Geology Exploration for Freeport-McMoran. In the summer, the former graduates of the Colorado School of Mine get together and they have a 1-week seminar over in Boulder, or in Golden. And this year they came here for 2 days and wandered around. So I got to wander around with 20 or 30 geologists trying to understand what they were saying. And a lot of it was a lot of fun. But at the end, one of the strange things is that the type of geology we have here isn't exclusive. Other places have limestone and shale. Other places have folded blocks. Other places have the different types of mountains. But silver is here. And why is it here and not somewhere else? And the bottom line that I got from Ralph was, Well, it's because it's where you find it. Okay? And if you've been looking at this photo for a minute of a beautiful mountain, silver is where you find it. There's a cabin or a tunnel in the middle of that mountain. So it's where you find it.
What mountain?
I'll leave you with that. Now, I have got to play with this. Lisa, am I allowed to pass this around?
Yes.
Ooh.
Though we will be looking for it.
Ooh.
Will be returned.
Ooh. I don't know if I'm going to share it. Okay. Silver is normally amalgamous. It's usually with lead, zinc, and copper. Well, occasionally you will find it in its pure state. If you're very lucky, you may find a piece of wire silver. This is pure silver. It's found in a small crack. Forget this piece, that's a piece of galena. But that is a piece of pure wire silver. And in Smuggler and Denali and occasionally on Aspen Mountain, they found elaborate pieces of wire silver.
How big?
This we will be checking for bags too. But that is a piece of pure wire silver.
Like what size would they find that?
Huh?
What size would it be?
It was that size. They
Oh,
just find little
not
pieces
bigger,
like.
not bigger.
No, not bigger than that. Occasionally, if you're lucky, you might break the rock away and find a nugget of pure silver. That's my nugget.
Wow.
This is the museum's nugget! But this is only a fraction of the nugget. We're pretty sure by the provenance where this came from. In 1894, in Aspen, in the Smuggler Mine, they retrieved a solid nugget of silver. Now, they had been finding nuggets of silver, 400 pounds, 600 pounds, 300 pounds. They had found many of them, but not in Smuggler Mountain. Denali had a couple of tiny ones. Well, in 1893, before the crash of silver, they had found a tiny vug. A vug is a hollow, natural hollow bubble in the mountain. And it was about the size of a Volkswagen van. And when you find a vug, that's where a lot of the moisture and the crystals begin to grow. And they found hanging in the ceiling a nugget, as well as several other nuggets lying around. It turned out to be a very rich treasure trove. That was in 1893. The price of silver was going down. They said, wait a minute, let's wait till the price of silver comes up. The silver crash of 1893 put an end to that. So eventually they took the nugget out in 1894. It weighed 2,060 pounds. 1 ton of pure silver.
Wow.
Now, by the time they got it out and weighed it, it weighed 1,860 pounds.
By the time we got about 3 chunks.
There's a 12-pound piece in the Denver Museum of Natural History. The rest of it was melted down, except for the missing silver. And this comes from a longtime mining family who were here in 1894. So we're just saying that, imagine this weighing 1 ton. That is the largest silver nugget mined on the planet Earth. And there's a 4,000-pound nugget supposedly in Europe, but they can't prove it. So we're going to go with that. So I'm going to pass that around and the silver. And I hope we've had fun with geology. I hope next time you go out and look at Aspen Mountain, you look at it different. Next time you find a rock that's round in the wrong place, you'll know that it is an erratic rock. So that'll give you kind of an idea. And I hope hope you had some fun. Next week, we're going to do the Smuggler Mine, the history of the Smuggler Mine. Because it's such a perfect example of a mine in the 1880s. It went through every single possible phase that could happen to a mine. It's a perfect
The
example.
class is gonna be at the line.
No, we're gonna be ready. No, they do tours at the mine. If you wanted to take one, but you have to call. And I would suggest that you ask for the 2 ROSMDs.
Yes.
Yeah, and specifically for Larry, because otherwise if it's just 1 or 2 of you, Jay will do it by himself. I do the big groups most of the time. So, any questions, any ideas, anything? Yes.
Was there silver oxide in there? Somebody had told me it was a sandy material, and they could just scoop it up and put it in bags. Probably not true.
No.
Lead carbonate.
Yeah, the lead carbonate, but even that, they had to crush it with the concentrators. What they did is they crushed it in the concentrators. There were several mills in town, and they would crush it. And generally, the concentrators here, they would crush it and then put it on Wilfie tables or Hallett tables, which have riffles in them, and it's at an angle, and it shakes and vibrates. You may have seen one, and they have some water running over it, and the light material, which washes away, and the heavy material gets stuck in the rivulets and collects and creates a concentrate. And so that may be what they're referring
Yeah,
to,
maybe that.
concentrates. Yeah, I'm not familiar with the oxides.
What
Yes.
is this a picture of?
I don't know.
Oh,
I believe this is near the Montezuma,
oh.
but I'm not quite sure. I think this is to the east of the Montezuma.
It's an unidentified wildlife.
Unfortunately, what happens is people who took photographs back then were the same as people who take photographs today. They don't label them. So we're not real sure. Sometimes we can guess, sometimes we can't. In the Colorado School of the Colorado National Mining Museum in Leadville, they have a photograph that's about this big, and it's a huge cliff, almost cliff. It's got trees in it, and it must be 2 square miles. And right in the middle is a cabin in a mine. And I have no idea. They didn't have helicopters back then. I have no idea how they got there. But, you know, it's where you find it.
You want to go into how they discovered there was silver actually in Leadville before they all...
Oh, sure. What happened was, actually I should go way back. 1871, when Hayden started his expedition. In 1871, 3 prospectors were on Mount Bloss, which is southeast of Leadville. They were at 13,700 feet. And for some strange reason, they found limestone. Now, they were passing by looking for gold. They weren't looking for silver. But sure enough, they found some lead carbonate lying on the ground and some pieces of silver. Now, this is mind-blowing in 1871 because where do you find silver? You find it in igneous rock granite with gold. It took them years to figure out that it was in limestone. And so by the time Hayden started his expedition, they knew that they could find silver in this dark matrix called lead carbonate, which had, well, in the 1860s, they had a gold rush in California Gulch. If you've been to Leadville, there's California Gulch. And they were looking for gold, and they panned gold. It was placer. And it was a town called Oro City. But what happened was, they began to run out of gold. And what gold they had kept getting stuck in this gooey black mud, which at the time they didn't know was lead carbonate. So a couple of fellows were hired to survey some mines. They were mining engineers, and they were hired to survey some mines and some of the placerings in Leadville and try to figure out a way to get rid of this black mud. Well, they looked at it for a while, and as I recall, they started buying claims. They're not dumb. Turns out it's lead carbonate, and it's got high concentrations of silver. So, in 1877, Oro City becomes Leadville. And Leadville turns into a town of about 20 or 30,000 people within a year and a half. So that's what happened. So it was lead carbonate. But it was, what happens is if you look at Leadville, the valley that Leadville's in, that's part of the same ocean that was here. And it's the same layers of shale. So when Hayden came through here and he described the shale here, they said, wait a minute, that's the Belden Shale and the Leadville Limestone that we've got over here. So what did the prospectors do? That's when they came over here. He published his works in 1878. So by 1879, prospectors were suddenly starting to do something different. They were starting to think that maybe these mining engineers and geologists, we ought to start listening to them. That's what they did, and that's why they came here, and that's why Aspen is here. So, that's what
Any silver to be discovered in this?
yeah, this is about 6 months old. Okay? This is about 6 months old. I may have carried this out myself. So there is silver. Now, the problem is, there is silver, but the economics aren't here. Okay? Today's silver was at $16.54 an ounce. It cost the miners, I think they figured it out, somewhere between $800 and $1,200 a foot to mine today. And you've got to find somebody that's not an RO SMD. You've got to find a younger SMD. And right now there's only one. So it's very difficult. The economics just aren't there.
Why did you polish the end of it?
Because it's such a soft rock, I wet sanded it.
I see. It was for your own.
Fred cut it with a rock cutting blade, a tile saw, and then I took and wet sanded it with some 400.
When you talk about the lead carbonate, is that the shale?
The lead carbonate, no. The lead carbonate is one of those replacements. It's right next to the shale, and that's why you get some.
Let's give Larry another big round.